Hello viewers, I'm back again, Mr. Nyati, to continue with my presentations. Pardon my pen, just from having a class with the GCE candidates. That's just beside the point. The point is that subscribe to my YouTube channel, like the video, share it, and also leave a comment in the comment section that I may be able to get feedback. This is physics, science 5124-1. So basically this is physics, and today we're going to go to grade 12 internal past paper 2024 in section B. I thought we should look at section B, try to solve one or two questions, particularly the first question, question B1. Okay, the question reads, the figure, which is figure B1.1, is showing the time recorded on a stopwatch for 40 seconds, for 40 complete oscillations by a learner during an experiment on a simple pendulum. And then we have this stopwatch, and it shows 1 minute 40 seconds. Okay, then we are told to say state the time taken in seconds for the 40 oscillations. Okay, so now what we need to understand on the simple pendulum is that there are those terminologies that you need to acclimatize yourself with. I know maybe a question may not be asked, but you need to know them, and these are such as period of a simple pendulum, period, which is basically the time taken for one complete oscillation, the time taken for one complete oscillation to occur, oscillation to occur. Please, this is not oscillation, this is oscillation to occur. That is what we call period. The other one is frequency, which is basically the number of oscillations taken or completed in 1 second. The number of oscillations in 1 second or per given time. Okay, so what does this mean? Period has a symbol of capital T, and then it is measured in seconds. The formula for period, since we are saying it's time taken per complete oscillation, we're going to say period is time taken per complete oscillation. Frequency, on the other hand, has the symbol of small letter f. Okay, let me write that again. This one, okay? And the formula is frequency is equal to number of oscillations per time given. And so, because these two are somehow similar, except that they are in opposite, okay? In this case, we have T over number of oscillations on N. Here we have N over T. So because of that, they are a reciprocal of each other. What does that mean? You can also write the formula of period as 1 over frequency. You can also write the formula for frequency as being 1 over period. This is correct. This is also correct. That's what you need to know. And so when we go back to the question, we are told, actually, I thought I should just highlight these before we proceed. Of course, this question is simple. State the time taken in seconds for the 40 oscillations. So state simply means that you have to state. It's something that you are able to see, but state it. Okay? So for this question B1, A, the time taken is 1 minute 40 seconds. So this 1 minute has to be converted to seconds. So now the question is, how many minutes are in 1 second? At least we know that 1 minute is equal to 60 seconds. Okay, so here we already have 60 seconds plus the 40 seconds. This one gives us 100 seconds. So the answer here is 100 seconds. Okay, this is the answer. You can also write it in this way, 100 seconds, either of the two. Okay, we move on. Calculate the period of the pendulum. Okay, so when we want to calculate the period of the pendulum, we need to first of all collect data that has been given to us. What is the data that has been given to us? Okay, so this is what we are going to write. The data that has been given to us in the question, we have identified, or we have discovered that there are 100 seconds, which is time taken, 100 seconds. What else? Well, the question says there are 40 complete oscillations. So number of oscillations, we have 40. What is the question demanding? Period. What is the period? We don't know. We need to calculate that. So we come to the formula. What is the formula for finding the period? Well, period of a pendulum is equal to time taken over number of oscillations. From the data, at least we are able to substitute correctly to say, well, 100 seconds is for time over 40 oscillations. What is the answer? The answer is 2.5 seconds. Now, what the examiner will give you, if this question has 2 marks, let me just find out. Well, it has 2 marks. 1 mark is not for the formula. There is no mark for a formula. The 1 mark is for correct substitution on the formula. The other mark is the correct answer with appropriate units. That is what the marker is going to reward you with. Okay? So we move on to the next question. So now let's duplicate this in the answer sheet that we've just created. All right. So this is how you calculate. I just had to do this, pre-doing of this, writing of this. Then we move forward to question B, Roman, because what we were calculating with regards to period was question B1. Now we go to question B2, which says calculate the two frequency of the pendulum. So, well, from the formula that we had arrived at, we can use either of the two to find the answer. So we can use either this or this to find the answer, and it is going to give us the same answer. So B2. If you want to use this method, I'll call it method 1. Method 1, where you write the data. What is the data? Well, at least we now have period, which is 2.5 seconds. What else do we have? Well, we have number of oscillations, which is 40, and we have time, which is 100 seconds, but we don't have frequency. So if we use method 1, we then have to use this formula, which says frequency is equal to number of oscillations over time taken. What is the number of oscillations? The number of oscillations is 40 over the time taken, which is 100 seconds. What are we getting? We are getting 0.4 Hz. These are the units for frequency. Well, if we are to go with method 2, allow me to get an extra sheet of paper. If we are to go with method 2, we will definitely find the same answer. So we are going to say from the data, say method 2, using the same data, we just say frequency is equal to 1 over period. What is the period? 1 over what period did we find? Here we had found 2.5. So we are going to say 2.5 seconds. Okay, so if we are to remove this, we need to multiply this. If we say this, we need to multiply this by 10, even this one by 10, so that we have 10 over 25. 25 into 10, 0 point, add a 0. 25 into 100 gives us 4 Hz. So whichever way you are going to use to find the frequency, to still give you the same answer. So I hope this was helpful. Bye-bye.